your talks. Okay, do we have all the panelists for the first talk? Is it just Rick that we have there?
Yep.
All right. I believe we have everyone, so without further ado, let me just quickly introduce the panel. We're going to have 4 talks, 10 minutes each. They are listed on the agenda. I will dispense with individual introductions, rely on the speakers to do that instead in order to conserve the time. Time limit is going to be strictly enforced. Everybody gets 10 minutes. Terrible things will happen after that. We're trying to conserve the time for the 20-minute discussion. And if you are not a panelist, if you're not part of the team presenting a given talk, please turn your video off, right? Questions to panelists, please put them in Q&A and please put them in chat. We will then have discussion at the end and hope to handle the ones that are not answered, right? And with this introduction, without further ado, I'm going to turn it over to Rick Anderson, who will be our first presenter and will tell us about self-driving cars in his lab.
All right, well, thank you very much. Oh my goodness, I'm very excited. So yeah, I'm Rick Anderson. I'm Director of Virtual Worlds and Game Research and Immersive Design at Rutgers University. I partner with a lot of different people around the university to deal with like augmented reality, and also one of the other hats is I'm co-founder of the Rutgers Makerspace. So I've been doing virtual projects and then real life projects. And so virtualization has been a big deal. And I've been, for the last several years, incorporating machine learning, robots, and game all together. So when I got to do driving autonomous cars with Chiat Edge, I was incredibly excited. I had worked on a plan to virtualize my project like 3 years ago. And like, this actually is kind of how I imagined doing it. So let me give some background here. I'll start with my pandemic story, which is that I do workshops, teacher trainings, and like I work with various people on their research projects. So what was going on was we went into COVID and we had to like still do our projects, keep them all going. So I had these cars the students had to set up. So they ended up, instead of like it all being set up in the classroom and everybody worked together to help each other out, now everyone was like setting up their vehicles independently. So the group I was working at the time was Bergen County Vocational School. And it was quite a challenge because we spent a lot of time installing software. It was like the cars were perfectly fine. Everything else was fine, but spending all that time on like, how do you install your software and debug, you know, things about these virtual vehicles or real vehicles in your house, you know? So it was a little really chaotic, and we weren't able to spend the time like doing the activity. So that was like, holy, how do we adapt? So I'm like, oh man. So I found a way to adapt using Chiat Edge. So first, I have a little bit, what is this FooCars project? So that's the project I brought. There's an open source project by Fubar Labs, which is a makerspace in New Jersey. And they've been doing like racing autonomous vehicles for a while. So there's a whole open source code set for that. So the FooCars are based off of it. And you bring a fleet of cars that are all Raspberry Pis, RC vehicles. And this is something that if people are familiar with the donkey car, it came up kind of in parallel. So you'll see some donkey car stuff and you'll see some things. So we went from 3D printed to laser cut and changed all these different things around. And it went from like creating the fleet of vehicles to, let's see, sorry, I'm getting notifications, to like going to Milwaukee Maker Faire and having kids actually play with the trained vehicle and change the track and do all of these things to sort of push the boundaries of what the car knows. So let's zip out of this one. So that was kind of like, so we have prehistory, we have what can these vehicles do? So what we ended up doing was using Chiat Edge to kind of take it from the art project where every single car is a work of art to make it more reusable and more like a fleet of cars. And how would you set that up, make it available? So we did things that basically took the building and debugging of the car and reduced that amount of time, and was able to move it to the machine learning and to do the focused course. So that also meant being able to do repetitive tasks of like, how do we provision a car, who gets a car, run the car software in containers. So we were able to virtualize it. So the software is pre-configured, dropped onto the Raspberry Pi, and the car is good to go. So you could swap those in and out. And that was something that Chia Edge allowed us to do using like the leases and the various things that you kind of saw in the workshop earlier. So we could run the car in the containers. And then I also could bring in the Jupyter notebooks and take what I'd sort of organized in Google Colab and bring it into the same environment that I'm using with the car. So the Jupyter notebook can actually engage the Raspberry Pi and turn off and on the lights. You know, they can engage the vehicle at these different levels. And it's kind of, it's just like, once you put in the work, it's kind of amazing how that starts to, you know, save you time and let you focus on the project at hand. So yeah, that was huge. And that is essentially, this transformation has allowed us to sort of make it so that the mentors that I work with, the teachers that I'm training, can spend more time with the students on working vehicles rather than configuring vehicles. So this is the stuff that I did with Mike in the group. Was we had the internship group. So it was Isaac, Sahithi, Mike, and I think all sorts of people jumped in and helped. So you know, Mike can talk to any of the stuff that we worked on together, but basically making everything modular was what we focused on. So it was like, collect the data, drive the car manually, or use an existing data set, curate the data, view it in Jupyter Hub. What's the interesting stuff? What can we train on? So training was offload to the cloud for speed. So that was amazing. Being able to go to the cloud, train up a new model and bring that out. The other thing was having a home base in the cloud, train up new images that I deployed onto the car. That was great. So we could also collect our results. So those results are collected and then they go into like a you know, a Docker container, not container, but a volume. And we could actually get that data pretty smoothly and then basically set it up to analyze the results and get a complete test out of it. So we were now able to, you know, benchmark everything across the board. So it was like speed or regularity, all of those things, but it brought up a lot of questions about, say, hardware and software. So I'll let Mike talk a little bit about that, because that was absolutely one of those amazing moments.
Yeah, so if you can hop to the next slide. I filled in for I filled in for the teacher role. We had a couple of very good interns this summer. And so they were able to take what Rick had been doing in workshops and build a notebook that would actually do all of those steps and collect data and plot it. And really got some results with what had been before a really manual process. So it was great to see all of that work end to end.
Mm-hmm. Yeah, I was super excited because like we put the effort in and then the data was coming out, and you know, it was super cool. And I have another slide that isn't as important as most of the other stuff, but it's that since I focus on everything from university to high school to vocational and workshops and teachers, we have this weird part where people are fabricating changes to the vehicles, people are testing code changes, and others are pushing the boundaries as to what the ML knows. So I feel like I've got this setup where I can have these vehicles be a fleet and available to my workshop, to my class, to the instructors that would want to use them. And I'm looking forward to like basically having a library of cars that are checked out and available for people to test with. So that would lead to the the future. I'm really excited that in some point of the future, we'll be able to check out a car of your own. And so I'm Rick, and I build the AI Maker series and, you know, teacher training, all that. So that's a super fast version.
Thank you, Rick. This was very exciting. This was very amazing. We're going to move on, but I have a question for you in the panel, specifically for you. Hongwei and team, you're on.
Thank you.
Thanks, Rick.
All right. So, okay. Good afternoon, everyone. Thanks, Kate, for the opportunity to share a few thoughts here. So, Let me see. Can you all see my screen now?
Recording in progress.
Okay, great. So I'm a professor of computer engineering at Iowa State University, and I'm leading the ARA Wireless Living Lab effort that Deep briefly mentioned earlier. So in the past months, we have had the pleasure of working Kate and her team in try to build ARA leveraging the Chi in the box framework. So here I'm going to share a few high-level thoughts about the ARA project and how it relates to the Chi at Edge initiative. And then in the second session, we have our students working with Mike and other folks in probably on a more specific demo here. So the broad context for the ARA project is look at the broadband challenge, right? As we know that rural broadband is a foundation for the rural economy and communities in general. However, there are, so if you look at the state, the current status, over 39% of the rural US lacks broadband access, and most of the ag farms are not connected at all. So one of the key objectives for the ARA project is to provide a wireless living lab to enable the broad stakeholder communities to work together to drive research, education, innovation in rural wireless and their applications in rural communities. So as a testbed, as a living lab, so there are two primary focus. One is to look at the missing technology elements beyond what's available today, right? Whether they are 5G, Neo Satcom, and so on. Besides some of the, the core technology issues to be addressed, one objective here is to develop technologies that would actually reduce the capex by a factor of 10 or more so that we can make rural broadband as affordable as urban broadband. And then in terms of the use cases, we will actually focus on the rural industries in addition to support more traditional connectivity needs in the communities. For example, there will be a major focus on the agriculture as part of the the living lab build out. So just a few notes on the living lab itself. It's designed to capture two main technology platforms, I guess, main technology substrate. One is the middle mile. The question there is, how do we provide high capacity, affordable, backhaul, wireless backhaul solution? And then on top of that, there's a question of how do we provide access networks so that we can bring the farms and communities to the backhaul, and then from the backhaul to the rest of the internet. So just a little bit detail on the technology elements. For the middle mile, the ARA solution, it's going to embody a diverse set of terrestrial and Neo Satcom capabilities, ranging from optical to millimeter wave to microwave and so on bands. For example, there's this free space optical link, that platform we will develop that can provide up to 160 gig BPS capacity over a distance of 15 kilometers. Now, leveraging this platform, ARA will enable a diverse set of research activities so that we can potentially develop capabilities that enables robust high capacity connectivity to the rural regions. And then on the access network side, this is where ARA is going to feature those 5G and beyond type of solutions, including the low UHF mice and MIMO platform that has both programmable cards solution, but also enables whole stack innovation. Now, together with ARA, essentially the ARA Run will enable the whole stack innovation and research, including spectrum innovation. That's actually one of the key barriers to the penetration of wireless into the rural regions too. Now, besides supporting our wireless research, there's a huge focus on integrating wireless research with application trials. As part of the ARA project itself, we're going to focus on the agriculture and education. What you see here are some of the examples. In the interest of time, I'm going to skip the details. You are welcome to look at the website arawireless.org for details, where we can chat at the panel session on details. So what I want to share, I think in the rest of the few minutes I have here is to take you through some of the high-level thinking on how we can actually transform this diverse set of hardware platforms into a research instrument. And part of that would be the question of how to manage the heterogeneous resources. This is where the Qi in a box framework would really help a lot, in particular with Qi at Edge in the near term. So to approach this, one perspective of looking at what ARA Living Lab or wireless networks in general are the observation that more or less you can treat wireless networks as the traditional kind of computers and networks plus some of the state-of-the-art RF equipment, right? So therefore, one key task here is to manage the various computer and network resources, which I think the Qi box framework has been really good at, right? And that Kate's team has been developing in the past years. So that's the approach we take, essentially, where we kind of divide the whole end-to-end ARA infrastructure into multiple segments. With for example, there's ARA Cloud, and then the ARA RAM, right? ARA Cloud is where you can find all those computing and network resources from the cloud to the edge, and then ARA RAM. This is where you can take everything all the way to take things to the field. And then if you look at what's available in this infrastructure, there's actually computing resources everywhere. Right? So that's where we are leveraging the Qi in a box framework and also in general OpenStack framework to manage these resources. So we have been working with Kate's team in bringing up one of the proof of concept sandbox setup that's actually mimicking the architecture of the ARA itself. So in session 2, there's another short talk about that. So I'll leave the details to that discussion. But what I want to share here is that, on one hand, there's actually a lot to be leveraged to kind of leverage what's available already to build the ARA software baseline. But on the other hand, of course, there are two pieces to the wireless network, right? There's a computing networking, but also there's the RF equipment. So we do actually have the ability to extend the Qi at Edge and OpenStack, some of the OpenStack components to support this future generation of wireless network infrastructures. So here are some examples. So for example, there's the opportunity of looking at how do we model and manage the wireless resources. One of the well-known, I think, effort from the Continuum project is the Blazor project, right? Actually helped refine and extend the Blazor OpenStack project Blazor. So we would envision that we could add, the spectrum and radio reservation capabilities to that, and that can be fed back to the open source community. So I guess another dimension that's introduced by the wireless resource is the safety guard. How do we make sure that the experiments will not actually violate the specification of the specification. So therefore, we have to put safeguard at the various layers. So that's something that can also, bring some new capabilities to the Qi at Edge software framework. So looking forward, once we get the ARA up and running, so given that we all use the same software management framework, I think there's a great opportunity of integrating the ARA infrastructure with the Qi at Edge and the Continuum infrastructure in general to enable experimentation across the whole field to the cloud continuum. So that we will be looking forward to some of those opportunities down the road, hopefully, probably in the coming in about maybe 2 or 3 years once we have the ARA up and running. All right, that's all I have, Kate. Thank you.
Yeah, thank you very much. Fabulous presentation, and we are so happy to have you as a partner and you and your team in developing the Blazor capabilities. The Florida International University team, you guys are on, and I see Leonardo.
Hi, Kate. How are you?
Hi, I am
Can
good.
you see? Good, and can you see my slides?
We can see your slides.
Okay, great. Thank you, Kate, for the invitation. I think we have been really excited to work with Chameleon in this project. So our title is One Fish, Two Fish, Choosing Optimal Edge Topologies for Real-Time Autonomous Fish Service. And this is a joint project that was done through Jonathan Tsen, who did an internship this summer with Kate and with Jason. And Jason and Jonathan are highly kind of like the main guys here. And so I think Kate had 2 questions, and myself. I mean, my name is Leonardo. I'm from Computer Information Sciences here from International University. And I have Kevin Boswell and Camilo Roa, who are from the Institute of Environment. And Kate had 3 questions, one about the problem, one about the edge computing. So Kevin is going to talk about the problem, and Jonathan and maybe Jason can put some thoughts there about the edge computing. I'm going to talk about what are the capabilities and what are the thoughts and how do we see this collaboration in the future. So I have maybe, Kevin, are you there?
I am here. Hopefully you can hear me.
Yes.
All right, great. Hello, everyone. Thank you for the opportunity to participate in this. So I'm associate professor in the biology department within the Institute of Environment at FIU. I primarily count fish. So my interest comes from a biologist's point of view, but we tend to utilize and rely on the use of advanced technologies for a lot of the work we do. So this is a really natural fit to some of the work we're doing, and it comes from recognition that we need ways of surveying and collecting data in these coastal and marine environments, or just aquatic environments in general, which of course are all exposed to various pressures and threats. And in some aspects, the ability to quantify processes or responses in these ecosystems is difficult and challenging. And so we've been, over the last several years, developing ways of using autonomous systems to service platforms to host a variety of sensors or devices or instruments that can be automated in their use throughout the ecosystem, do so in a non-invasive way, but then also collect really high resolution information, be it a bathymetric map, be it the distribution of animals, listening to sounds that characterize the ecosystem and help identify threats, but also important measurements to help understand the quality or condition of an ecosystem. And so this was a really natural fit, like I mentioned, and this partnership or collaboration that was developed has been really interesting and exciting. But some of the challenges, Leo, can you go to the next slide, please? Some of the challenges or the research that we're interested in moving forward with now is to, one, understand, can these autonomous platforms be used to efficiently survey in these areas? And can the data that are collected from them help to describe or quantify the status of the ecosystem? And so then from there, of course, we move into some of the challenges that we've been focusing on most recently, which is, how do you collect data? What's the most efficient way to do it? If you collect data from an autonomous vessel, you can network to it. And then if you can network to it in real time, you can access the data. And then you can make decisions based on what those instruments are measuring. And then we get to, interact with different ways of analyzing this data, thinking about, do we do these processes on board? Do we send them to the cloud and try to get real-time information to then improve or alter our strategy for collecting data? And then, of course, this gets into some of the other details of, the specifics and network quality, network criteria, depending on bandwidth and how much is required in order to develop a useful data product that we can then use in real time to, again, make decisions for adaptive sampling and things like that. And maybe at the same time, offer a whole nother host of information or data products that lead to, a better understanding of the biological systems. And so we've been spending time really discussing this, and it's been a fascinating approach, at least for me, from the biologist point of view, is to think about, the realm that I live in, trying to count and measure animals with those of this broader group, and building on the benefits that you guys have done with computing power, and it's been fascinating. So thank you.
Jonathan, are you there?
Yep, my internet just fell down. I just connected to that. Okay, so Basically, coming from, especially from Brazil, as a researcher in Brazil, so some things that I notice is because we have a lot of challenges of operating from like remotely, especially now that I'm here in Brazil, to the Cloud-Chameleon that is in the United States. So many of these barriers can overcome with Chameleon Cloud. So I put some topics there of like what barriers we can overcome or facilitate with that. So the basically one is the convenience of choosing between bare metals, especially from cheat edge, CUC, and GTAC. So if you want to have access to a Jetson Nano, you can go to cheat edge. Raspberry Pi, if you want to have a powerful GPU, you can go to CUC, GTAC. So that's one of the things that we can overcome and facilitate with it. Another thing is easy access to change the source codes. So basically, if I'm here from Brazil, I want to connect to the autonomous vehicles there at FIU, and I'm not there physically, I'm not there with the computer, I'm not there programming, I can with Chameleon Cloud, I can program here from my home in Brazil, send and do all of this change of source codes directly to the autonomous vehicles in FIU. So one of the questions before was about the camera. So yeah, we are implementing these cameras, we're collecting underwater videos from the Raspberry Pi, sending to the cloud, and then there we are using all of the AI stuff. So, and then another topic is having access to powerful GPUs that allow us to train and improve AI on models more efficiently. So if I wanted to use my computer GPU, it would take like several hours or days, but having access to these GPUs from Chameleon Cloud, we can basically train an AI model in like a couple hours, 8 hours, 10 hours. So that's very, very nice. And the last topic is Chameleon has several security systems that allow me to have a reliable remote access. So I don't need to worry about security issues, like not that much, because Chameleon was built on a lot of security systems, and that helps a lot, especially being here from Brazil, starting doing this all remote now. So yeah, that's going to be very nice to do.
Thank you, Jonathan. So I just have a small slide of some of the results that Jonathan was talking about. He was able to train a lot of deep learning models that were, I guess, impressive in terms of the results from the point of view of Kevin, like finding, and I think that's kind of like the things that I want to talk about. I think this is our big vision that I put in that picture on the left about autonomous system and how can we use autonomous system to support this research on environmental questions. So we have this idea of incorporating data sources from heterogeneous group of vehicles because they represent different aspects of the phenomena. We have surface vehicles that have certain sensors, we have underwater vehicles, we have a set of buoys, we're also interested in spectral drones, and of course, remote sensing from satellite data. And how are we going to integrate that? One thing that is kind of my thought is that all the computation and storage requirements that we'll need to run some of these algorithms will exceed the capacity of these devices. So for sure, we're going to need edge connections or cloud connection. I think this is a great opportunity that we're going to have here. And we are continuing thinking about what other kind of sensing modalities we can explore. We have hyperspectral, we have also try to reconstruct certain other computer vision aspects of the type of fish and corals. And remote sensing, as I was mentioning, due to the huge storage requirements that we have. And we are trying to kind of like other things that Kevin was mentioning and we're interested to is having models about oceanic models or hydrodynamics models or diffusion models. And it will be wonderful to take advantage of this opportunity, knowing that also there's a lot of people in Chameleon that has this expertise. And of course, planning is one of the things we're interested in. And having this edge capability in these autonomous vehicles, I think will open a range of possibilities for us. Thank you, Kate.
Yeah, thanks. Thank you guys very much. That was extremely interesting. I knew about the project before, but I learned new things today, which is wonderful. Okay, and last but not least, we've got the FlyNet team. FlyNet team, you are on. Okay. Mike and Eric, are we going to see you? Don't forget to decloak.
I couldn't find the unmute button. I apologize very much. Sorry. When you go in presentation mode, everything moves away from your regular screen in Zoom, so that makes it look difficult. So welcome everybody, and sorry for the little technical issues here. So I think I'm going to start a little bit different, slightly the different approach than the presenters before me, and going higher level, and then I will switch over to my colleague Eric, who is giving a quick demo to show you how we're using what we've put in place so far for some of our research, some of the validation of our architecture. So I'm going to talk about the FlyNet project. That's a deeply programmable end-to-end network-centric platform for edge-to-compute workflows. That's a CC Star that's funded out of NSF's CC Star program, collaboration between UMass, RENCI, UC ISI, and University of Missouri. Eric and I are going to present, but we represent the whole FlyNet team here. I have to make sure here's a high-level overview. So we really, what we want to build is an architecture and tools that allow researchers to use the edge to core continuum for their research. And we're using drone applications to show, to demonstrate that how we can use that. And we're focusing on that here. But in the long term, we just don't think we should be limited. We saw some of the examples already today where I think, what we're building could be a nice support for these applications. And then we're highly thinking and including also Chameleon Cloud, and in the future, Chameleon at the Edge in our work. And we're using other testbeds that are available or becoming available, like, for the past years, Genie, and also coming up Fabric for our for the development and the usage of these tools. So what you see here is the overall architecture with the continuum on the bottom side, and it shows you that you should be able, as a researcher in the future, to set up workflows that use edge devices, edge servers, networks that allow you to use in-network processing that as Fabric will do in the future, all the way out to the core cloud, either cloud testbeds, which we have with Chameleon and Cloud Lab, or even commercial clouds with AWS and their brothers and sisters, and so on, all the way out, based on what computational needs you have and based on what latency requirements you have. And so I think that's one of the important things I want to highlight here is that, with some of the applications, everything autonomous, drones, self-driving cars, and so on, latency becomes an issue. And so we want to be able that you can set up workflows that can include edge computing, so you can at least somehow mitigate for that latency to a certain extent. Initially in our project, we're using it, looking at drone video analytics and route planning for drones, especially the planning around weather, as we show down here, because as you can imagine, flying drones through weather, especially the smaller ones, is not a very good idea. The project has 4 major tasks: the integration of cutting-edge computer networking infrastructure, in-network processing, obviously, because some things you can do in the edge, but even if you can do things in network, you can, again, cut down on the latency. You have to have monitoring, right? You want to see how your workflows are performing. Are there any issues? And then in collaboration with Eva and her team at ISI, leverage the Pegasus workflow management system for in-network and edge processing. Since I have the opportunity here, I'll put a couple of things down where I think we have needs when we look at Chai at the edges, especially since we do this we want to build an emulation environment in a distributed fashion. Stitching is a really important topic for us because we want to have control of the network and have the network kind of be predictable and not necessarily always go over the public internet. In some cases that makes sense. In some cases, it's better to know really what you have in terms of a network. Integration of third-party IoT resources. I think Chai at Edge is making wonderful strides there. For us, sometimes it's also important to have long-term reservations because we want to try out new tools and see, be able to work on them over time. And then actually what you're doing right now today, best practices, right? Talk to other folks that are on the workshop today and see what experience they have, get tips. So how can we improve the usage at Chameleon and Chameleon at the Edge? Just a slide demo here, how we use this. Shows you how you route a drone around weather. And you see this is an algorithm that gets new updates. And so based on the movement and the prediction of the weather, you can see that the path of the drone can become over time a lot shorter than originally planned. So here you can see that, updated weather information, communication between the drone and the edge becomes really important. I want to give you a quick overview on what Eric's going to show you, and there's a lot of information on the slide. So what I really think you should take away from here is that we're using different test beds. We're using Chameleon. We have to wean ourselves of that. Still using Exogeny as long as we can. It's up and running to do some of the simulation and then in analysis of our architecture. For example, always flying a drone is pretty cost and time expensive. So we're doing some emulation here, but we're running other parts of our workflow then on different cloud components. Here, for example, to emulate a small edge server that does video analytics and having a video analytics server that can also run on a larger cloud, for example, if you want to use that for training. So these are the different components, and that's coming back to where Chameleon at the edge is going to be important, but we also think that the stitching part is going to be important because we want to connect these components tightly together. And so with that, I would like to hand over to Eric. Eric, I'll stop sharing here, and then you can switch over and go into your demo.
Okay. Thanks, Mike.
Sure.
Okay, I just want to advertise this high-level slide quickly. So as Mike's slide showed, we have this notion for an experiment where we were going to take a drone and basically fly a path, and with the notion that the drone may well be communicating over like cellular links, and at any given time, the drone may be able to communicate with multiple different cell towers, even on multiple different networks, depending on what kind of radios it might have. So again, this is in simulation. In real life, the drone may have just a small edge device. It's just reporting like its position or whatever. And also for our experiment, the drone is gonna be collecting video. And so what we want to do is essentially be able to stream off the video to edge servers located in various places. You could have more than one. So to instantiate this, this was initially on the Chameleon cloud. We obtained 2 servers and we gave them public IP addresses. And then we notionally represented in simulation these being edge servers, but actually did map their public IP addresses back into the system so that we could actually do real tests. So as the drone flies, we actually do some short bandwidth measurements to each of these edge devices in a simulated way. I mean, excuse me, the iPerf measurements are real. So we calculate bandwidth, and then we emulate the network that you might get based on distance from each individual cell tower site, plus a little bit of randomness that is realistic in the field. And then what we do is we send data. We have an optimization function that determines how and where to send our video data batches as the drone flies. And we actually do go ahead and implement it. So initially, this was not on Chiat Edge or Chiat Edge, but actually not in the end-to-end system, but in the individual modules. We have, in fact, recently brought in images onto Chiat Edge, like, for example, iPerf 3 server images, and tested bandwidth measurements to these smaller devices. And also an FFmpeg server, which is going to actually be the thing that receives our video that we are sending from the drone. And I think Ryan Tanaka later on today will show some results from that. But without further ado, let me show how this all works here. Let's see. Okay, so we have our Google Maps image. Each of these pink circles represents like a cell tower. These small boxes represent like a processing station for your video data. And we assign at random, every time this increments, just some random load. The cell towers have a bandwidth and a signal level that's realistic depending on the distance from the cell tower, and also an RTT. And as we cycle it through here, our optimization function takes into account the instantaneous load on these Chameleon devices, which is actually being measured in real time with a Prometheus interface. And it takes into account the bandwidth that we have to these different cell tower sites. And then like the RTT, and you have a weighting function depending on your applications that require a lot of bandwidth, like for example, video streaming, the bandwidth might be favored in the optimization. And then you fly the route and you determine what the best path and what the best location is to send it. And so we see this as an example, but with drones being possibly, you know, a developing field that's going to be using these edge devices, particularly if they're shared edge devices, we thought this framework might be useful for different applications and on how to use the edge in different ways. So I'll stop there.
Thank you, Eric. So I think I want to finish with already giving a big thank you to the Chiat Edge development team. As you can saw, and a few points where Eric pointed that out, we have started transitioning over to Chiat Edge, and the team has been really wonderful with supporting us and helping us with you know, some of the things, the issues we ran into. That was really a wonderful collaboration, and we're looking forward on you know, continuing that. Thank you.
Thanks, Mike. We're looking forward to working with you more as well. As always, many thanks to all the presenters. Please decloak and join us in the panel now. So thank you for your wonderful presentations. Were very, very interesting, and thank you also for staying on time. Everybody was very, very disciplined about that. Those are fantastic applications. I realize that it's hard to stay on time. Stop talking about them. Okay, Hongwei and Rick and the FIU team, please decloak and join us on the panel. We would like to start asking questions. Also, yes, Chameleon team, please join us on the panel as well. If you cannot decloak, we understand, but it would be good to see you. All right, so also a quick note to the audience. I see that there's a little bit of a discussion going there for ARA specifically, but it would be also good if you have questions to the panelists. This is the time to ask them. And I will start with a quick question. So all of you described different aspects of using Chiat Edge, and the question is, which edge testbed features are most useful to you at this point? So is it making your devices shareable? Is it the fact that there's access via Jupyter Notebook, federated login, or is it the edge to cloud type of thing, right? Is it the fact that from the same Jupyter Notebook you can access edge devices and the cloud? What is most useful at this point?
This is Leonardo. I don't know who is my camera. It says that I cannot start my video, but because the host has stopped it. But anyway, so I would say like the Jupyter. Now I can start my video. I think yes now. So I think the Jupyter Notebook was a big plus for us because before we start the whole kind of collaboration, we had some initial code in Jupyter. So it makes sense to so we have this preliminary version in Jupyter, so it will make sense to migrate this to Jupyter. And I think the other part is access to the GPUs, what Jonathan was mentioning, right? We need this kind of capabilities to be able to train and test these models before deployments, right? I think those are two big factors that I think that make things smooth for us.
Yeah, I plus one the Jupyter Notebook. And also for me, because I have these vehicles that need leasing, you all jumped in and really helped out a lot, but there is at least a leasing capability. So I can say these are for my project, and that really helped say these are the cars that I'm using and people have it in use or not in use. So that was a really cool feature, and I know it kind of came up on the fly. So.
Any other comments on this?
Yeah, I have a quick one. Sorry, I was muted again. I don't know what I'm doing today. Sorry, but for us, it's more the edge to cloud combination of resources. With Mobius, we're having a tool developed by the Renzi folks that programmatically can allocate resources. So Jupyter Notebook is not, I see the importance for some applications, but it's not as important for us. But for us, it's really because we're on this cloud to edge cloud continuum, having this where we can get if I may say it this way, package of resources that include both through one control instance, through one framework. That's really neat. We really like that.
Yeah, and there's a flip question to all of that. What do you think are the biggest shortcomings right now in what the platform provides? Nobody wants to.
Well, I mean, for me, it was sort of the building as we go. There's a lot of things that that are almost there. So, for instance, we don't want to run the Raspberry Pis in privileged mode. We want to use the features and then have those in, like say, these are the features I want, and it shouldn't be like give complete access to the device. So it turns out that that's pretty buried pretty far down, and you have to wait for a Blazor update. So it's not the group or anything. It's just the stack of technology has this part that's way down. So we just have to wait for that.
Well, that's good. That's good feedback. That's Hongwei, do you want to weigh in on any of this?
So I guess in terms of feature, there was some side channel discussion already. I feel that being able to allow seamless integration of edge to the cloud, and even I think that function would be really useful for especially for domain scientists. I think in the field.
Yeah. Okay, this is all useful feedback. In the meantime, we also have been posing a sort of a version of this question to the audience, and some people participated. And it looks like the edge to cloud continuum wins out in this, right? The ability to access both edge and cloud devices. People perceive that as very useful. Let's try a different question. For the edge device hardware that we provide right now, right? So it looks like they are making my devices shareable. For this group, not very popular, but edge device hardware, what edge devices, what types should we provide? Should it be more low power edge devices, like let's say those Raspberry Pis, or higher power edge devices like Jetson or the AGX, like high end, or maybe x86 edge servers, just full-blown servers? Would you like FPGAs, GPUs, TPUs, anything like that?
All of it, right? If you ask me what I'd like, right? So that's the question. I think from the experience we had so far, I think more variety in capability. So not like this version of the Raspberry Pi and that version of the Raspberry Pi, or something that's very comparable to it, but having something that is really kind of a small footprint edge device, then maybe something that's more powerful with a GPU like a Jetson Nano, up to an 86 infrastructure. So you can actually then test different scenarios with different edge devices, right? Sometimes, so for us, for example, Ryan, and I apologize, Ryan, I don't know if you talk about this later, he's looking into, like, for our video analytics, which is the right edge device, right? And so having these different categories is really nice, because that helps us identifying that, right? Or I should say, which edge device has the right capability to perform the analysis in real time, right? And so that helps us for our case, but I don't know if that's important for anything else.
So I hear more variety. In the meantime, I'm sorry, I made a mistake. I accidentally, and I see somebody already fixed this mistake. That's fantastic. So more variety is a good answer. Anybody else?
For us, I think especially we want to reproduce the same experiment on like more boats or autonomous vehicles. I think for us, it will be better having more Jetson Nanos because of the latency, because especially deploying our autonomous vehicles in the field, like there's a lot of latency, local internet connection. So having Jetson Nanos that have GPUs processing all of this data inside of the autonomous vehicles, and then after processing it, sending just the results to the cloud. For us, especially at FIU, the best option would be the Jetson Nanos.
So more GPUs in general, right? More devices with GPUs in general. That doesn't have to be the Nano, right? It could be something else also.
Yes.
So maybe Kate, I can add a point here. I think just echoing probably the value of enable diverse use cases, right? I think probably As we think about the testbed, probably the realization in the coming years, I think maybe it seems that most of the edge devices are tied to specific use cases, right? I think if we can enable like coverage of representative scenarios, use cases, that may actually help, especially for scenarios you want to look at the end-to-end networking, including wireless and computing, right? Not just computing. I think that would be really helpful in general.
So it looks like you're agreeing with Mike is that just essentially more diversity is better, right? Because people can experiment with those devices maybe before they get them for themselves or anything like that. That makes good sense. That is to get a preview of the capabilities of the device.
Yeah, I guess I was saying also diversity may have multiple dimensions, right? There's besides equipment device itself, there may be the specific context, environment conditions that are used, if that can be captured in some way.
Well, so the context is, I mean, I think that that's a good point because actually the other question I was going to ask is about peripherals, right? So the devices are configured in special ways. And they could be configured as with cameras, or they could be configured with SDRs, as in your case, more likely, right? So I think the next question is, what data sources would you be interested in? What data sources do you envision those devices working with? Are you thinking cameras? Are you thinking SDRs? What should we be thinking in terms of interfacing those devices to?
Maybe Kevin can comment on this. I think for sure we want to still have cameras. I think Kevin uses a lot of acoustic sensors and sonars and general kind of like let's say spatiotemporal physics sensor like temperature, pH, salinity, and these things. So I think sensing connection of sensors will be kind of one big thing for us. Like environmental sensors, yes. So it'll be cameras and environmental sensors and
cameras and environmental sensors.
Sonars and acoustics. I think these are the type of sensor that Kevin uses in his lab.
Okay. That makes sense. Anybody else? Does anybody else?
I would, the feature that I benefited from was registering my own vehicles with my cameras and my sensors. So essentially that allowed me to have like, what should my camera see? Right. So when I'm testing the camera, I'm either testing it in a vehicle in motion or that sort of environment. So that's kind of not quite what should be in She at Edge, but because you have that capability, I'm able to configure what I want to see for the test I want to do. So it's a little tangent from the question.
No, that makes perfect sense actually. But from our perspective, if you're interested in certain data sources, right, we're going to have to provide some sort of support for it. And extensible framework is one thing, but having some types that use support out of the box, I think lowers the entry barrier for users, makes it possible for them to get started quickly. So that's kind of, that was the background of my question. I completely understand. And sort of to speak to the same set of concerns, what images should we make available, right, for the off the bat, easy to get started? Is there, should we have some sort of image processing on them, TensorFlow, CUDA, any kind of other software that you can think of that would be good to have available, right when you get started? I mean, you can always install your own software on the image and snapshot it, but what would be good to have as stock images? As I'm sure that Drew will be interested in the answer there because she will be the one that provides those things.
Kate, if I can just quickly, because there was a Q&A question about the camera specifically, I wanted to briefly take while people are answering. This was from Iram, said it was basically interested in cameras. We'd like it to be extended. Are there any plans to do that and how much time? And I guess I want to say we're looking at this from like two different perspectives. One is, I think as Kate said, supporting kind of more standard cameras that are like on market and already have good interoperability with containers. If you've worked with these devices before, you may be familiar with that. It can be often pretty painful to integrate them with containers because the vendors maybe assume that you're working on more of a bare metal situation. So it takes some time. So that's one perspective, is basically solving the 80% case. The other side of it is if you have very special needs for special type of camera, or something you built yourself, or something you're repurposing from another area, what we want to do, and what we are doing internally, is making a sort of plugin architecture that allows you to write Python, a little adapter that basically just tells the system, like, here's how you plug the container into the camera, or vice versa. So there's not a whole, like, I guess we're talking about re-enrolling the SDK, looking at like Q1 of next year. This is sort of part and parcel of that, in my view, but we don't have a fixed timeline on when we would be expanding that aspect of the platform.
Okay, so for the images, I see that there are some answers to the poll that we're getting, that TensorFlow is very popular, but do people have favorites? So to get back to that?
Well, not exactly on that side, but you know, from what we presented, also monitoring capability, right? So there might be, you know, having like something like Prometheus already in the image would be nice, because you know, we all do this to maybe, you know, publish or do evaluations later on it. So being able to collect some sort of information about the system's behavior, that would be a wonderful service, because you have it then right there. And you know, I mean, something like Prometheus is kind of a, I don't know, and I always think it's almost a standard, right? So having that, then you can have a nice way, you can run your own server, collect that, or run an instance at Chameleon, right? And so that might be something in addition, just kind of on the maintenance observation side, so to speak, right?
Yeah, we use Prometheus on the operations side, but we were not using it in images per se. But if I understand what you're saying is, you would like easy access to metrics that you can get yourself anyways, right? With a little bit of work, right? And not access to metrics that you can't get from the container, right? That we would have to provide like power measurement metrics sometimes. Okay.
So give you a quick example. So sometimes, you know, if you really think of multi-tenancy at edges, right? You want to think about, this is what I can measure on my container, but what's the overall system load on the system, right? And what impact does that have on my container pack? And so to answer this question, I think you have to have bigger picture information. Yeah.
Now this is very timely intervention, because we're actually talking about providing Prometheus in some way in images, and I think it would take a little bit teasing apart to do that, or to do that scalably. Okay. Anything else? Anybody else would you like to have on your images, or provided as something that is ready-made that you don't have to configure yourself?
I think for us, especially doing a lot of image processing and OpenCV, like every time that I need to create a new bare metal, I need to install first thing, just install OpenCV. So that was a very that would be, I think, a very nice library to already have when you open it up. But yeah, just CUDA was so useful. Oh my gosh, CUDA, already having CUDA there was like a big plus, you know. But yeah, for me, OpenCV.
Okay.
One thing that came up in one of the earlier questions that might tie in here is a way to talk to sort of IoT devices that aren't necessarily able to run the containers. So if there was an existing like OpenHAB or other things that are made for dealing with IoT data, would that be of interest?
You know, one thing that I see that Rick works, I mean, I'm come from a robotics background, and I know Rick has some work there in robotics, and I think Michael I think he showed some drones. So I think in robotics, we have this ROS, the robot operating system. So that's a de facto standard for a lot of things that happen in robotics. So they have a ULXC simulator, they have a lot of libraries to connect to different kind of like available robots, right? If there is any way that I guess Chameleon can connect to ROS, I think that can benefit the robotics community.
Yeah, that's fantastic comment. That's all good feedback. Okay, I think that we're almost at the end of the panel. One last question to everybody. What would you say should be our priorities? We could, add more features. We could get the system out of preview, which we could provide. We could restore the SDK availability. What would you vote for? From your perspective, what makes the most sense? It's a tough one.
You want everything, right? So that's the
Yes,
point.
yes,
But I
yes.
think you guys have done.
You should have provided. Yeah.
You guys have done a fantastic job of rolling this out. I think not taking a breather, but hardening things, right? So they were at least over time. And this is there's no criticism. That's just what happens to all of us, right?
Mm-hmm.
So I think making things more reliable, more predictable. For now. Is probably, from my point of view, I would prioritize on that and then think into new features. So think about new features. But that's my point, my view on this.
Anybody else wants to weigh in? I should say that we all got a lot of wonderful, very specific, nitty-gritty feedback from all of you, and we're very, very grateful for that. Yeah, somebody wanted to speak? It's hard to time things in those sessions. All right, one last question, and it's I originally meant it as a question for Rick, but it's really a question for everybody. Rick, you're developing those Jupyter notebooks with lesson plans for those self-driving cars. Would you be willing to share those with others? I mean, I can imagine that for some people that could make a difference between running an operation similar to yours and not.
Yeah, I'm absolutely willing to share and also participate in developing them to be better. The capabilities that are now on the table, it's so exciting, and they weren't there when I started. So I'm adding on to the Jupyter notebooks to support things that this environment is providing. So yeah, I'd be happy to share and happy to work with.
All right, fantastic. Well, thank you, all of our presenters. Thanks very much for your projects and your hard work and your lovely presentations. We are going to take a 13-minute break at this point. And please don't go away, come back, because we're going to have a fantastic keynote after the break and another very exciting session.
Thank you, Jason.
Yeah.
Bye.
Okay.
All right. Thank you, everybody.
We're going to be back in 13 minutes.